Okay, here's some answers for the differentiation quiz that people seem to suffer a little bit with. So I'll go through these as quickly as I can while still explaining them, but obviously any rules that I reference you might need to look up. So, part A, this one is officially a chain rule, but as we know, I have a little step that I use to skip this. So what I do is I multiply by this number, which is here, there's 2 multiplied by the differential of the bracket. So I'm just differentiating this whole thing here now. So I'll get 2x, take 2, and then I leave the bracket as it was, so I just rewrite this thing out. So I get x squared, take 2x plus 3, take 1 off the power, which leaves this as a 1 here, which means I don't need to write it. Then I'm just really looking to simplify at this point. Now, to expand this whole thing out would be a bit time consuming, a bit unnecessary, but one thing I can do are these 2 2's here. I want to pull them out of the front of that bracket. So what I'm going to do is when I pull these 2's out of the front, I essentially get this. All right. Now this is going to obviously just simplify down to 2 times 2 here, which is 4. X take 2. X squared take 2x plus 3. And I'm done there because there's no need to simplify. So moving on to the next one, part B. So part B, this is a u over v. This is a quotient rule. Okay, so considering that this is a u over v, my rule says that when I differentiate this, it's going to become u dash v, take v dash u all over v squared. So my u is 2x squared, take 3, my v is x squared. So all I need to do is u dash is 4x, take nothing at all, and v is equal to 2x. So now I'm just following my rule from up above. So I'm just going to go u dash times by v, which is 4x times by x squared, take v dash times by u. So I've got 2x squared, take 3, all over v squared. So I'll get x squared squared. Alright, so cancelling this down a little bit now. So I'm going to get 4x cubed over here. Multiplying out this bracket, I'm going to get negative 4x cubed. Take. Now, this is, I've got to be careful here because this is technically 2x here multiplied by negative 3. But then I've got a negative here, so this is actually going to be plus 6x all over x to the 4th. Now, a common mistake here seemed to be obviously recognizing that these two would go and leaving the answer as 6x over x to the 4th. But we should be cancelling this x with one of these, making this a 3. So our final answer in this case, I don't want to do sausage maths, should be 6 over x cubed. Moving on. So this one here, the main difficulty with this is recognizing that square root is equal to the power of a half. Once you've got that, the rest's pretty easy, just like this one above that we had here, this part A. So I'm just going to do a half times by the differential of the bracket, which is 2x, times by the original bracket, which is x squared, take 3, take 1 off the power, which is negative a half. The half times 2x, a lot of people struggling to cancel that thing down, which I really don't think should be happening at this point. And then this, we could leave it like this, but it would be neater to recognize that this was actually equivalent. There's negative a half. The negative pushes it down to the bottom of the fraction, and the half is a square root. So this is our ideal way of leaving this answer. So this one over here, the main thing with this, I mean, look, we can chain rule it. So we can see this as 2 sine u. I'm just going to get rid of this from here. 2 sine u is our y in this case. and our u is x squared. And then we can just chain rule this one. So in this case, we're going to get dy by du is equal to 2 cos u, and we're going to get u du by dx is equal to 2x. So when we multiply these two together, we're going to get dy by dx is equal to dy by du multiplied by du by dx. So this is actually equal to 2 cos u multiplied by 2x. So this actually comes out at the front as 4x cos, and then instead of writing u, I'm going to put back in what was in there originally. So I get this as my answer. Part E. So this one is a uv. This is a product rule. So we've got u multiplied by v. Our u in this case is x cubed. Our v is sine x. Differentiating, we're going to get v dash is equal to cos x. And u dash is equal to 3x squared. To differentiate our product rule, we just do u dash v added to v dash u. So when we get this, we're just going to go u dash v over there. This, oh dear, this is 3x squared times by sine of x. Not sure what we're going to be able to do with this to cancel it. And then we're going to get v dash u added onto this. So 3x cubed cos x. Now, really for cancelling of this, we could leave it like that. One thing we might do is pull the x squared out the bracket and just leave 3x sine x plus x. Oh no. 3 sine x plus x cos x. But there's nothing much else we can do at this point to simplify that, so we'll stick there. Our next one, and I think final part of this first page, this is another quotient rule. So this is a u over v. This is, in this case, we've got u is equal to sine x. V is equal to e to the x. U dash is therefore cos x again. V dash is equal to e to the x, because e to the x just does nothing. So we've got u dash v, take v dash u, all over v squared is how we differentiate this. So u dash v, we've got ex cos x. Take v dash u, we've got ex sine x. And all over v squared, we've got ex, all being squared. Now, what we should be able to see at this point is actually these ex's, we can divide through the whole thing by a single ex. So what we'll end up with is cos x, take sine x, all over e to the x. All right. Now, this part G, this is just another quotient rule. I seem to have enjoyed them on this quiz. So we've got a u over v. So we've got u is equal to log e to the x, otherwise known as ln of x. So we've got v is equal to 3x. V dash is therefore just 3. And u dash is equal to 1 over x. Okay, again, you can look this up. If you don't remember how to differentiate log e to the x, have a look up in your notes. So we've then just got u dash v, take v dash u, all over v squared. So this is going to give us u dash v is 3x times by 1 on x. Take v dash u, which is 3 log e to the x, all over v squared, which is 3x squared. And then we just get, if we multiply this thing out, this x is essentially going to cancel with this and just give us 3. Take 3 log x all over 9x squared. Now, we can do a bit of cancelling with this. Obviously, if we pull this 3 out the front, we get 3, 1 take log e to the x all over 3 times 3x squared. So these two can just cancel. And we'll get our final answer as 1 take log e to the x all over 3x squared. The very final part of this first section is another product rule. So this is essentially a u times by a v. In this case, we've got u is equal to 5 e to the 3x, and our v is equal to cos 2x. So getting slightly harsher on what we're trying to differentiate here. Now this, we're going to multiply by this, the differential of this 3x, all right, which is just 3. So we're going to multiply the 5 by the 3, so we get 15 e to the 3x. Again, have a look back into differentiating e if you need to. And then we're going to get v dash is equal to differentiate what's inside the bracket, which makes 2 times by cos 2x differentiate, which is just negative sine 2x. So we'll get negative 2 sine 2x. Then we just got u dash v plus v dash u to find out our differential of this. So we get u dash v, this times by this. So we'll get 15 e to the 3x times by cos 2x plus v dash u. So we'll actually get, take away 10 times e to the 3x times sine 2x. Now we can pull out the front here if we want to get really jazzy, 5e to the 3x, and just have left inside the bracket 3 cos 2x and take 2 sine 2x. But it doesn't make it look much nicer. But there's our answer, and that's the first section, which was those sort of 8 parts all rolled in, all done. So next up, question 2.